I bought a microscope yesterday, and there was a splotch on it, and I couldn't figure out what it is, and I did the scientific method trying to figure out where in the microscope the splotch was coming from. Turns out I was seeing a reflection of my optic nerve.
Nice.
Yeah, you can look in the microscope a really long time and you won't find that.
Yeah.
So when you gaze into the microscope gazes back into you.
Also gazes back. Microscope.
Are you saying that what you see inside Dave's eyes is the abyss?
Yes.
Yeah.
I just want to know how he proved that hypothesis false. Did he gouge one of his eyes out?
Actually, and this is the part that I was very, very proud of. I finally switched eyes, and the splotch moved and changed shape.
Oh, that's brilliant.
Wow.
Does this microscope make my optic nerve look fat? This podcast is sponsored by New Relic. To track and optimize your application's performance, go to rubyrogues.com/New Relic. Does your application need to send emails? Did you know that 20% of all email doesn't even get delivered to the inbox? SendGrid can help you get your message delivered every time. Go to rubyrogues.com/SendGrid, sign up for free, and tell them thanks. DevMind is a software design and development studio in Chicago with expertise in Ruby, JavaScript, and Clojure. We believe that well-crafted software makes life better, and our team of designers and engineers is dedicated to that pursuit. We love our customers, we love our team, and we spend a lot of time and effort making sure that we fit the right projects with the right people. Get in touch at devmind.com. That's DEVMYND.com. Hey, everybody, and welcome to episode 150 of the Ruby Rogues podcast. This week on our panel, we have Josh Susser.
Hey, good morning from sunny California.
James Edward Gray.
Good morning, everyone.
Avdi Grimm.
Good morning from snowy Pennsylvania.
David Brady.
Good morning from Utah, which is maintaining the conservation of fog with San Francisco.
I'm Charles Max Wood from devchat.tv, and we have a special guest this week, and that is Danielle Sucher.
Good morning from New York City.
Can we get an introduction from you?
Sure. Hi, I'm Danielle, as you now know. I live here in New York. I work at a nonprofit called Case Commons, where we do case management software for social workers. I spend most of my time outside of work reading, hacking open source, and petting my cat, who is very pretty.
Awesome.
Very nice. All right, well, we brought you on this week to talk about debugging. And you gave a talk recently about the debugging mindset and deduction.
Yeah, I gave a talk at just a local meetup, New York Ruby Women. Most of it was trying to explain the idea of approaching debugging in terms of just verifying facts and evaluating the evidence. Like half my slides were screenshots of Sherlock.
That was what sold me on the talk, actually. It's all pictures of Sherlock taken from the BBC series, which is just awesome.
I found that actually really disorienting. Every time I saw a picture of Sherlock there, I was like, oh, that was such a great episode. Oh, wait, what was this slide about?
But the show is awesome because it's all about science.
Yes.
It's really good.
I can totally see why James liked it. Science, Sherlock, and coding.
Yeah, it's my kind of stuff, huh? So you have tons of good tips in here, but I think one of my favorites is the one that you actually just start off with it about what to do when you get an error message. Do you want to talk about that? Because I'm sure I'm guilty of this all the time.
I have to teach this regularly. Yes, please.
I can sum it all up in one word. Blame.
No, I think the blame is useful, and we should absolutely talk about it. And I mean that seriously. But I actually also have to teach people to read error messages all the time, which is why I put it in there. It seems sort of weird, telling people, have you tried reading the error message? But I forget to too. I get all excited. I think, oh, I know what's going on here. I don't need to read this. And then I have to flip back and look at it again.
I wonder if it's almost gray page syndrome, where, like, when Ruby throws an error message, it really throws an error message, right? I mean, you get the stack dump is like 79 lines long, and half of it's in active record if it's a Rails project. And so you just assume that you've core dumped, right? So, whatever, gray page, I'm just going to guess what went wrong. And like, no, read, look for the lines that aren't Rails. It's right there.
I believe one of the secrets of pair programming is that the other person, because they're not typing, is actually reading the error messages.
That's actually a big part of it.
Yeah, having someone to just say, hey, can we just flip back to the terminal, please? I didn't catch the number.
Right.
Yeah. What was that line number? Yeah. The thing about the stack traces as a starting point, though, is it seems like half the time when the lines that I really want to be looking at in the stack trace have been elided. It's just like Ruby or Rails or somebody tries to omit. It's that gray wall syndrome or the gray screen syndrome Dave was just talking about.
Yeah.
It's like, oh, we don't want to show you all the stuff that you probably don't care about. So you're like, I'm walking down through the stack trace and I see 10 lines omitted. Damn it. That's right where it was.
Yeah, well, and on that error page that you get from Rails, the default one, it always shows you it's like application trace, and then it's like the framework trace, and then there's the full trace. Mm-hmm. And it always shows me the one that doesn't have the right information in it.
Yeah.
Yeah, but this is Ruby. I mean, if you say put in a debugger and then call caller, you can get more information.
Yep.
Awesome tip. Yeah, that's actually on one of your slides. I think people forget about that. If you ever want to see the trace at any point in the program, there's a method called caller that will give it to you. So puts caller and you can see the full trace, not omitted at all.
I actually wrote a module called Where Am I? Because the module introduces another layer to the caller. It basically, all Where Am I does is it returns the caller, but up 2 levels. So basically, you can now say, where am I in your code? And it will tell you who called you.
I remember that trick.
Mm-hmm.
Yeah.
Yep.
That's great. I like that a lot.
So I kind of want to ask this. In the calendar, it said the debugging mindset. And we're kind of talking about in the trenches techniques for doing this stuff. Is there an actual mindset to this?
Yeah, I think there is. I think that a lot of people sort of focus in on, okay, I know what's going on, and I'm going to go through my whole application trying to figure out where I am. But it's really simple. It's you want to figure out what the facts are. Stop assuming. Mm-hmm. What are the facts? What is the state of the world? What did I change recently that I can look at? I mean, we just can't hold that many things in our head. So anything that lets us simplify, and focus in is really what's critical.
Yeah. I worked on a system where every time we got a bug, I would do a git log and I would look for a particular developer's name. And
ouch.
It was brutal, but 80% of the time that took me to where the error was.
I mean, I'm more thinking, so in Coders at Work, which is this collection of interviews that Peter Seibel did, there was one with Joe Armstrong, who's one of the guys who wrote Erlang. And he had this great line where he talked about how he thinks all errors are pretty much within 3 statements of the place where you last changed your code.
Yeah.
His story is about, he said he debugged a hardware problem that way, actually, without knowing anything about it, just by saying, what did you touch last?
So part of the mindset then is just to gather information as opposed to just saying, oh, I know where things are?
I always think of it this way. If you get too deep into studying the brain and how the brain works, one of the big realizations everybody has at some point is that your reality is not recorded, it's constructed. Right? So you like to think that the brain is just a big video camera in our head and that whatever we see, it records all that, and that's the way it is. But the truth is that your brain is constructing reality, your reality around you, and that means that you can be fooled, right? Because your brain misinterprets some signals or whatever, and so the construction of reality it has is not actually accurate to what's going on. And then you can't be dissuaded of that because you experienced it. You know that's the way it is, right? That's the problem.
Yeah, it's like, I never touched a line of code in that file. I swear.
Right. Yeah, that, right?
Yeah, it's so easy to convince ourselves, yeah.
Well, the truth is everybody else's code is total crap, so.
Did I tell you guys the Argle Bargle story? This is a really short story, but have I told it already?
I don't think so.
No.
So I dump cache in my brain every 2 weeks. I do not remember what I've worked on 2 weeks ago. And there's a lot of programmers who can remember what they've worked on for, 6 months, a year ago. And I feel that's just a complete waste of time. I'd rather just get really good at reading code. So I stop remembering what I've written. And a coworker pointed at a piece of code and said, at the top of his screen, very top of his screen, he said, "Dave, what the hell are you doing here?" And I looked at it and I said, "Why are you asking me?" He said, "What the hell is this code doing?" And I said, "I have no idea. Why the hell are you asking me?" And he goes, "Because you wrote it." And I said, "I've never seen that piece of code before in my life." And he scrolled up one line and the comment was, "Argle Bargle." which is Dave Brady. It's like whenever I just have a kludgy hack that I just have to make it work, I write argle bargle on top of it. And it basically means what's about to follow is my best attempt at slinging crap on the wall to see what sticks. And I saw the argle bargle and I'm just like, busted. I have never seen that code. Like, I have no memory of this code. Like James is saying, my construction of reality has no recording of that code.
So then how'd you figure out what it did?
I sat down with him and I read the code.
See, that sounds to me like a really good argument for really thorough commit messages.
Yep.
Yeah.
Yeah, but what you're essentially doing is, you put argle bargle in there, and that's evidence that you wrote it and that it's a hack. And so what you're doing is you're setting yourself up so that you can go back later and look at that evidence and go, oh, this is a kludgy hack.
Exactly.
Or the commit messages.
Argle bargle says this is worth less than its stated face value. Yeah, exactly. Yeah. When you read this, read it with a squint.
But the trick there, the whole point of this discussion we're having right now, is that if you can accept that what you think you know at any given time is a construction and it's subject to validation, you can do a lot better, right? That's why reading the error message is like the best place to start. You may have an idea, you may think, but if the error message is pointing to the other side of the app, you need to just accept that your construction is probably wrong this time.
Right.
And you'll save yourself hours if you can make that step, right?
Step is so hard.
It is hard.
To get yourself to and to get other people to do it. Have you ever had the experience of sitting down with somebody and saying, let's start you doing unit tests, and they get offended that you want to spend all this time writing code that questions their ability to write a program?
Oh, jeez. I mean, I think I try to start these things with, okay, this is what I think is going wrong. How can I prove that I'm mistaken about that?
Right.
Yeah.
So what, admitting your ignorance is the beginning of wisdom?
Yeah.
Look, the goal is to prove that I'm wrong. That means I win. I've proved that I was stupid about something, so I can move on to being stupid about something more interesting.
Yeah.
Yep.
Right. If you can prove that it's not there, if you have this instinct, your brain may or may not let it go. So if you can just jump in there, throw in one line of code, rerun it, and you're like, well, that's never being called. Guess that's out,
Yep.
Then you can let that go and move on,
Mm-hmm.
Yeah.
Mm-hmm.
Yeah, that's another one. I mean, I feel like it's important to just, like I said, clear things out of your head. So, yeah, I want to follow the errors and go to what seems relevant, but I also want to just disprove the things I can disprove fast first to get them out of the way.
Danielle, in your slides, you have one slide that talks about searching in the light versus searching. Can you tell that story? Because it's a great story.
Oh, sure. It actually goes sort of two different ways. So there's this old joke where, some drunk guy is looking for their keys in the light, and someone goes, oh, hey, where'd you lose your keys? Let me help. Oh, well, I lost them over there on the other side of the parking lot. Well, then why are you looking over here? Well, this is where the light is. And
Yes.
the other point is, well, that's really stupid. You should really look where you dropped the keys. That's where you're going to find them. But I went to a Peter Norvig talk, actually, a few months back, where he talked about looking where the light is as the actual goal, because you start where you can find information and work out from there. So when I put that in my debugging talk, the idea was look where you can actually find information, see what you can gather from that, then move on to hunting in places that are perhaps trickier.
So
Google.
So Google, that's right. That is one of the slides. Go with it, yeah.
So if your unit test suite passes and you still have this bug, it's okay to have run the unit test suite because that's where the light is?
I don't think you know where the light is.
Well, yeah, but I mean, it's like when your keys are missing, right? Go quickly to the places where the light is. You might find your keys there, who knows? But I mean, you can very quickly go through it, and then it's out of your head, right? Like everything that we've tested in the unit test suite, I've got green dots across the screen. I know it's not in anything that we've covered in a test suite. I have to look outside that now.
The other thing is that if you go look where the light is, sometimes you could find like someone else's keys or a flashlight.
Yeah.
Nice.
Or a wallet, but I'm looking in some pretty rough streets.
I think
Or another car that somebody left the keys in.
Yeah. Getting them once you get them out of the car. Anyway,
I like the whole mindset conversation we're getting into here. This is basically, we're talking about the scientific method and disproving hypotheses to come to the conclusion. And a lot of this is talking about how you get the data to either formulate a hypothesis or to reach a conclusion. And I love the whole, walking through that process. The other fun detective show that I think has a great reference here is True Detective. And in the first episode, he says, do any of your books have anything about jumping to conclusions, where you prejudice your own ability to collect data, by forming a potential conclusion too early? And I think you mentioned that in here in one of your Sherlock slides.
I'm sure I do. I think it's such a big thing. Speaking about pairing, one of the things I think I learned from pairing is, I jump to a conclusion and say, okay, what are the 3 other possibilities that I can think of, just to force myself to slow down and actually think.
Mm-hmm. I think that, one of the things that I'll do when I'm really stuck trying to debug something is I will make sure that I prove that the obviously boneheaded ideas are bonehead. Like if I look at something and say, oh, it could never be that.
Yeah, that's a red flag.
Yeah.
Exactly.
As soon as if I can catch myself saying that, if I can notice that I just dismissed something without validating it like that, I will force myself to go back and verify that my assumption that it was stupid was actually stupid.
I have a canned phrase that I use. I love it when my pair says that. Oh, it can't be this. And my judo sentence is that I say, fantastic, show me.
Yeah, for me, it's how do you know?
Yeah, how do you know?
Oh, nice.
Exactly.
Well, we've been dancing really close to the discussion of actually experimentation. Experimentation can be actually going through and reproducing the bug. They say, well, we sign in as this user, we click on this thing, and, it does something wrong. But we can also write tests that test the hypothesis. We can open up an IRB or Rails console or something like that, or Pry, and, really go in and experiment. And that's also a really good way to collect data. It's a little more work intensive than just looking through a stack trace and stuff, but it's a terrific way to just verify, certain conclusions. And if you validate that there is actually a problem there, then you can write a test around it because you just did the experiment.
I think one of the great things about having a good test suite is that I can often use that to narrow down large portions of the system. Like, if I run this test spec file, then doesn't that narrow it down to being in these, couple of objects, probably, or something? It allows me to quickly search through the system in slices and narrow it down. I'm sorry I cut you off, Opti. What were you going to say?
I was just going to say, I find myself so sort of naturally biased towards thinking through a solution, figuring it out by sheer force of will rather than making an experiment. Making an experiment always feels like work. And I always want to just stare at the code long enough to just see it. And that's not always a good attitude.
The trick that I do where I've poured my energy into getting good at reading code rather than remembering what I've written goes hand in hand with making experiments there's no latency, there's no impedance mismatch. Like if I'm like, oh, this doesn't work the way I think it's doing, I'm just going to break this expression completely and see if the code starts working or stops working in a different way. And the reason why is because basically I've deliberately made myself as stupid as possible. That doesn't sound as awesome outside my head as it did in. But I will look at the code and I'll just go, this code doesn't work and I don't want to think about why. What can I do to prove why it doesn't work? And so, I tend to come at it very outside in, and I treat even my own code like a hostile territory.
This seems like an excellent point to refer to the episode we did with Elizabeth Hendrickson on her book Explore It, which is
I was thinking that as well. Yes.
Yeah, it's all about exploratory testing. So we did a whole talk about a whole book about that whole subject.
Awesome.
Yeah, I was just thinking this reminded me of the thing where I'll write a test that I know is going to fail just so the way it fails can tell me what the hell's going on.
Right? Yeah, exactly. And then the look of shock on your face is great when it passes.
Oh, that's the worst.
Okay. So I need to point to the words that every programmer has uttered at some point in their career, which is
this is family friendly.
How did this ever work?
Yes.
Yes.
I was thinking of different words that every programmer says.
Well, there's those too. But
Did this ever work?
Yeah. So
I love I love getting to the how did this ever work.
So, like, Danielle, what do you do when you hit that point? How did this ever work?
Try to go back in history and see if it ever worked in the first place. I mean, there's no point in figuring out how it worked if it didn't work.
Often you can find code that was put in but never actually put into use, right?
Yes.
Yeah.
What I often find is I look at the code and I'll go, how did this ever work? And I will find it just upstream of it, 1 or 2 hops, a fold or a wrinkle in the code that causes the obviously broken code to never enter the broken state. Right. There's like this guard hidden upstream it's coupled, but there's nothing to express that coupling.
So in programming, 2 wrongs do make a right.
Yeah.
Absolutely.
Yeah. Sometimes.
Yeah. And a lot of times there are 2 pieces of code that are superficially similar, and one of them sort of fell into disuse, but never got deleted.
Yeah.
And that actually can be misleading when you're just debugging, because you can be sure that you found the issue when you get to that.
Code, it's so broken.
This clearly can't work. And you think you found the issue, and then you change it, and it still doesn't work. Yeah.
That's always the one that I wind up trying to fix.
That's when you just delete it and see what happens.
Right.
That's actually not a terrible idea.
I take it seriously.
No, it is. Like, programmers have this attachment that we place such high value on code. And actually, I think I finally got over this watching, I think it might have been Zed Shaw's Peep Code or something, where he is just really ruthless with git reset. I mean, he will figure the whole thing out. He's, ready to save the world, get reset, start over. It's that he loaded it into his head, and that was the key, right? That he loaded it into his head. And he doesn't need the code anymore. And he will just do that all the time. And I think we have a natural tendency to be afraid of that. But I've finally gotten over that. I've realized that, if I just deleted it, it's in Git somewhere. I can get it back if I have to, or whatever. So
Dan Mayer has been doing some interesting stuff with production code coverage testing, using tools to see which code is actually being used in production and which code is never touched. Then you're able to look at that report and go in and delete lots of code that actually is never being used. And I guess that relates to debugging, because that's a few hundred lines less that, you will be misled by.
Right.
Mm-hmm. That sounds awesome.
I guess you just have to be careful you don't take out all your error handling code.
Yeah. The big thing, especially with people coming from like big static languages, I'll find people that will comment out 100 lines of code and then leave it. They'll commit it. They'll leave it in the code base. And I delete that. I delete that ruthlessly. And they're like, no. And I'm like, dude, you can get it back.
Yeah, that's what Git's for.
Never will.
Yeah, that's right. Yeah, that's awesome. Can we circle back to this Google thing? Because I learned this lesson again yesterday. So, yeah, can we talk about the Googling problem?
Oh, sure. I mean, that's just another one that just feels so silly to bother to say out loud. Have you tried Googling the error message?
Right. So
people don't do it.
Yesterday at work, we had this problem. I knew I'd seen it a million times. I'm like, yeah, I think I know the algorithm. I Google it. I'm sitting there reading the algorithm page. I'm like halfway down it. I'm talking through the algorithm and how you do it. Meanwhile, my pair has intelligently gone to Stack Overflow, found the chunk of code, pulled it off. It's in the app. It's mostly working.
The best way to sound like an infallible guru while pairing, particularly while remote pairing so they can't see your screen, is just to, keep Googling things as they're debugging.
Dare I
and be like, well, have you tried this? And they're like, how did you know that?
Dare I admit that I do that on my coaching calls all the time? And the thing is that a lot of times it's pretty seamless, because I know where to find it is what it really boils down to, not necessarily that I knew it. And that's as much the advantage in coaching as, actually knowing it off the top of my head. And
that's actually a skill that you can learn and develop and get better at. Like, the whole Googling for error stuff
and reading Google results is a skill that you...
Yes, true.
Yeah.
Yes.
I have had Google fail me once in a hilarious way, and I had set up some PHP framework, like MediaWiki, or it was a big one, and I went to go to the homepage of the app, and I got this, oops, something's wrong in your setup, and then it just dumped all of the state variables, like you're running Apache version this, you're running PHP version this, da 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 da. So I took the message and I Googled it, and instead of getting back the solution and the fix, I got back a list of like over 10,000 websites that were up on the web with that framework installed wrong, and when Google indexed them, it got that full error page. So instead of getting the solution, I just realized I am not alone. Everyone's breaking this, and then apparently just deploying to production that way, which is awesome.
And those of you who are doing it sort of sneakily, so what you're saying is you're not teaching the people you're pairing with how to Google, huh?
Oh, no. I wanted to add a proviso to that, which is that I always share how I'm coming up with the answers. I always try to point out, the way I knew that was I went to Google, and you should too.
Yeah, it's so important. Like, we just have this, I guess it's hubris, that oh, I know what that error message means.
Yeah, I think a lot of this is fighting our own egos.
Yes. So I liked your zombie Richard Feynman reference. The ideas are tested by experiment. That is the core of science. Yeah, awesome. The other thing that, I love Feynman stories, of course, having gone to Caltech. One of the things, I'm sure I'd mentioned this on an episode before at least once, is, one of Feynman's stories is when he shows up at the Manhattan Project, and it's his first day and he knows nothing about what they're doing, and somebody rolls out a huge blueprint of the Oak Ridge gas diffusion setup, and he's like, okay, I have to show my ignorance here because I have no idea what they're talking about. So he just like randomly puts his finger down at some point on the blueprint and says, "What's this?"
No, tell me about what happens if this breaks.
Yeah, just like something like this. What about this? What if this breaks? And like the guys look at it and say, "Oh my God!" and they run out of the room.
Yeah. And he's like, "Oh crap! Now they think I know how to read blueprints."
But the point of that story is he just like sucked it up and said, "Okay, I'm going to show how little I know here and ask a stupid question." But it turned out that there was a lot of value in asking that stupid question.
Yeah.
And if he had been defensive about his ego and not showing his ignorance, the war could have turned out very differently, right?
Yeah.
Yeah, I think it's really helpful to be like, I don't know what the hell's going on here. That's really cool. Okay, let's talk about that.
Yeah. The war history would include the Oak Ridge gas plant disaster.
Yeah.
Story.
Right. So that's like, don't be afraid to ask dumb questions. But this, I think, goes well with you were talking about use a branch. And I love the use a branch to create an easy resettable environment where you can do these kind of experiments. And you have complete freedom to make as many changes as you want, because all you have to do is, git reset hardhead and you're back to where you were.
Mm-hmm.
I have to admit, I'm too much of a wimp to use reset that freely. I just end up with a lot of stashes.
Stashes,
okay.
Cool.
Stashes is actually kind of another form of reset, right?
Yeah.
It's just pull it off. That it makes us feel a little better because we know that we can stash apply and get it back, right?
Mm-hmm.
Yeah, just just comforting.
So you had a slide on this. Do you have any particular tips about using branches that you could share?
I mean, not so much branches, but there are definitely a few Git things that I think are super helpful.
Okay.
We were talking about blame earlier. That's a really big one. I really shied away from using blame for a long time because of the name, and I thought, well, I don't want to be mean and think about this person is wrong and I'm blaming them. This is not the attitude I want to come from.
But they're really wrong.
You can alias
it were me. I was wrong.
You can alias it to Git appreciate.
Oh, there you go.
Subversion had an alias for praise, and nobody used it, so they took it out.
I think I should alias it like Git. What were they thinking?
Yeah, get WTF.
Yeah, because really, I look at something and I think, I have no idea why they did this. What on earth is going on? What were they thinking? If only they'd left me a time capsule that told me exactly what the context was and what was in their heads. Oh gosh, they did.
Well, one nice thing about Git Blame is that if you look at it and it has their name and it says that they did it yesterday, usually their cache hasn't reset as
still in their head.
So you can go over and you can go, I'm having some trouble with this code, and that way you're not saying you screwed it up.
Yeah.
And then you can gather more information. You can validate certain parts of your hypothesis because they can at least walk you through the thought process behind that code.
Yeah. Or you do it and you see that this wasn't changed for 3 years, and this thing only broke yesterday, so this probably isn't the cause of the problem.
Right.
Mm-hmm.
I've actually done the go talk to a coworker who pushed yesterday, and I got everything I needed to know in one sentence, which was, "Oh crap, did that get pushed?"
Nice.
Oops.
Yep.
No, the git blame, I think, Danielle's right. We have this tendency, then we'll know who's wrong, but that can help in a lot of ways too. Not just, it's not about always putting the name with it. The way more important piece of information that it gives you is the git SHA for that line of code.
Yeah.
Then you feed that to git show, and then you get the commit message, the rest of the changes that were involved with that line. It gives you a more complete picture. It gives you the context, which is what matters, right?
Exactly. What changed at the same time, and why did they claim they were changing it?
Right.
I also want to point out, related to that, is that I find that in GitHub it's a lot easier to read the commit diff than on my command line.
It's a fair point, yeah.
And so a lot of times I'll take the SHA and I'll feed it to GitHub instead, and then just go look at the changes there.
Oh, that's cool.
I use gblame in Vim, which makes it really nice.
There's a thing I'd like to shout out to all of our listeners and get them to rebroadcast to everyone in the sound of their hearing. And that is, we've been talking about scientific method and skepticism and good thinking process, but there's something that scientists do, and that's that they keep good notes. So please, 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 please get in the habit of writing get in the discipline of writing good commit messages. Those are your notes that you're going to come back to later, or somebody else is going to have to come back and read. I hate when I find a 75 file commit and the commit message is fix.
Yeah.
Although when I'm git blaming something to figure out what went on, and the commit message is, "I'm a horrible person," I think I pretty much have a good idea.
I've done that.
Yeah. I remember that comment. "This is a crime against humanity."
Yes.
I think I wrote that comment. Okay. So I have a question about how you deal with bugs that are resistant to reproduction in development, but they show up in production.
Yes.
Yeah. Question 1, what is different about your production system? How can you make your development system more similar?
Mm-hmm.
Anything get closer. Or think about what are the differences, and what could those differences be causing?
Yeah, the worst case I ever had of that was that we had a production environment and then a staging environment that we always just deployed to check things out before pushing to production. And production was having this terrible bug and staging was just fine. And it turned out that we were using a different hardware load balancer for staging than we were in production. And it was terminating the SSL stuff differently. And it was completely hidden from development that we had these two different pieces of hardware.
SSL is an excellent example of something that's often different in production and development.
Right.
And this brings up an interesting question, because I wonder if it's always the best use of time and resources to try and make your development environment more like production versus trying to find some way of debugging on production. Because I think, those are great examples of how there are always going to be differences between production and development, and, even between production and staging. And it can be both very difficult to simulate those in development, and it can also be very difficult just to realize what those differences are. And that you can sink a lot of time into that. And I wonder if it's worthwhile.
Yeah.
That's a good question.
Yeah, that's actually really fair, because I've had problems where the differences were environment variables. You can't really solve that by making your systems more similar.
Yeah.
One of the common examples that bites me in that is Ruby's default encodings pull commonly from environment variables like LCC type. So, the system can be assuming UTF-8, then you get it somewhere where the server is different. It doesn't have LCC type, but it's set to what you expect, so it defaults to US ASCII, and there you go. There's your bug,
Or I had one on a staging server where someone had accidentally switched things around with RBN, and suddenly our server was using a different version of Ruby.
Wow.
So it's a little scary.
You just said a magic thing, though. Staging server.
Yes.
So the staging server is, in theory, all the real hardware and it's got full systems and it's got, right? I mean, it's going to go out and talk to VeriSign and Stripe and whatnot. And it's probably using testing account stuff, right? It's not running real credit cards, but it's as close as you can get. You're clearly
Except for
not
that darn
running
load balancer.
Yeah, exactly. Well,
same number of machines, same amount of data, and pretty similar data that's just been obfuscated. Exactly, as close as you can get.
I had a load balancer bug, and we solved it by putting a load balancer into staging. Like we didn't have a staging load balancer, so I'm like, nope, this has to go into staging.
But I think Avdi has a good point there about how that's a big rabbit hole. I mean, there's still going to be differences even between staging and production. How powerful is it to be able to SSH into production, fire up a console, and start typing some lines?
Oh, yeah.
James and Danielle, you both cited bugs that you solved that were production only. I'm curious, how did you find those?
Looking at the error message in the log, I swear I don't remember what it was, but it was something that I remembered had changed in a more recent version of Ruby, and that's what triggered me to think to check for that particular problem.
In our case, after I figured out it was an encoding bug and that I couldn't see anything wrong on my system, I just started thinking, okay, I guess we're talking about different encoding and I don't even have access to that production box. And I ended up asking our sysadmin, can you just run this line of Ruby and tell me what it outputs? And I basically just spit out like encoding default external or something and saw that it was different and assumed that was it.
Mm-hmm.
So you did, in effect, debug on the production server.
I did. Yep.
Now, the way that you approach that kind of stuff has to be really different. I feel like when I'm doing something on my dev box locally, that it's more like doing a chemistry experiment. But if I'm doing something on the server, it's more like I'm being an astronomer. And I'm looking at something that's happening far away that I can't really have control over what it's doing. All I can do is change how I'm looking at it.
Yeah, it's not like you're going to bundle open on your server and start messing around with things.
It's not like you should.
Right.
Right. And Ruby has historically sucked for this as well. I mean, there are other languages and frameworks which put a real premium on making it easy to debug in production. You know, there are ones that go as far, like, I think Seaside goes as far as basically like a failed request effectively just gets frozen and you can get in there and basically restart the code under debug on production where it failed. And we just don't have that kind of tooling.
Right. Since we don't have that tooling, what tooling do we have? I mean, you know, Danielle, you mentioned logs. People also use like error reporting services or collecting metrics.
Yeah, lots of error reporting and metric services. Things like New Relic people use for Rails applications, so you can see what kinds of errors are being thrown and stuff like that.
Or Rollbar or any of those services.
Yeah.
Okay. Is there any other tools that people commonly use for collecting that kind of information?
There are all sorts of monitoring tools. I've been messing around a little with Closure lately and contributing to an open source library called Remon, which does monitoring. It doesn't really matter what kind of system the events are coming in from, but it does all sorts of interesting aggregate functions on streams and can give you alerts any way you want.
Cool. What about like instrumenting your application to make it easier to debug production faults? So just like a little bit of prudence, and so that you have the right data when you need it.
I think there's an interesting balance you want to strike because you want enough data to debug, but not so much information coming through that it's hard to pay attention to the stuff that matters.
That's a really good point right there, right? The tendency is grab everything, right? But then if you bury yourself in data, you didn't make anything better.
Yeah. Well, there's an important distinction. There was a fantastic talk at Mountain West last year about the Air France flight that went down in the ocean from Malaysia. And he talked about information overload. And he showed this is what the cockpit of of a 747 looks like. And if you're not a pilot, it's terrifying, right? But then he said, it's not the amount of information that's the problem. It's what's called alert fatigue, where in addition to all this information, you've got this blaring 100 decibel klaxon that's going, and telling you something's very, very wrong. And so, you do want to be able to get everything, but you also need to be able to filter it so that you
Yes.
can turn things off,
Right.
even if it's after the fact with just grep.
Yeah, that's so critically important. Exactly.
I think one of the key things I try to use to make a decision about information I'm going to need later, when I'm programming it and I hit that interesting point where I find myself asking a question like, would it be better to do it this way or that way? It actually doesn't matter which one I choose. It just matters that I've realized that's a critical junction, and so I probably better tell myself what happened there, right? That if it's interesting enough for me to be posing questions like that, it's probably worth logging the metric and saying, oh, and in this case we chose that, and then at least I'll be able to look at it and see what happened, right?
I wonder, do you guys ever use log levels? So you just change the log level that your production app is running at for a given period of time, and then put things in, the guard clauses that check the log level?
I don't.
Honestly,
haven't.
no.
Yeah.
I think the problem with that approach, I get it and I like it, and I think the problem with it is that it's too hard to do. So you think, okay, I'll put in these extra debugging calls, so most of the time they won't be in there, and then I'll turn them on. So then you're debugging and you're working with the app, and you're like, there, that's it, that's the bug. And you're like, oh, I don't know what happened. Okay, I'll go back, kill the server, change the logging level, restart it, try to go through that process again and reproduce it. It's like, yeah, it's too much work to get back to that,
Yeah.
For me, the problem is that your entire code base is at log level 0 always when you read the source code.
Mm-hmm.
Yeah, that's true. Right. You have all these extra calls in there to log debug, and they don't ever go away, right?
Right.
Yeah, I think that point earlier about filtering through the logs is actually more helpful to me, making sure that anything I'm logging has like a nice, easy, greppable way of finding it, so I can just filter through and find the relevant stuff.
Yeah, I have to admit, it's an idea that I've thought about for a while, but I've never actually gotten around to implementing in any of my projects, so
yeah,
it's some interesting feedback. And if anyone's done that, I'd love to hear how it actually worked out or didn't.
We got lots of emails about how we're doing it wrong.
Well, if we were doing it right, it wouldn't be throwing exceptions, right?
That's right.
Yeah. Okay, Danielle, can you explain rubber duck debugging?
Yeah, I love this.
What is that? Quack.
Thank you. So the idea is, you have to, if you explain clearly to someone what the problem is, that will force you to actually pause and think about all of your assumptions and everything you think you know and what your knowledge is. And by the time you're finished explaining it, you'll probably figure it out by yourself anyway. And you don't have to explain to a person. You explain to your cat. You can explain to a rubber duck. It doesn't really matter. When I actually first gave the talk on this, I brought a bunch of tiny rubber ducks and gave them out to everyone in the room just to make sure they had someone to explain their problems to.
Everybody needs a friend.
Yeah.
The rubber duck works because it just sits there and bobs up and down. It listens to you, right? Dogs are great. I do this with my wife all the time, and I bet it drives her crazy because, halfway through the explaining the problem, you get the aha moment, and then you just stop talking, because you're like, I've got it. Now I just need to figure out how to, and then, you run off, and she's like, whatever.
Yeah, I do that to my husband. He's like, wait, no, this was interesting. I wanted to hear the rest of the story.
Right.
I just get that blank look from my wife, and then I get the smile, and is everything all right when I just stop talking and run back upstairs?
Yeah, you're going to be okay, right?
That's great. Danielle, I have one more thing to ask you about, and that's being right by accident.
Oh, boy.
Can you talk about that?
Yeah, when you change something and suddenly all your tests are green and everything works and you have no idea what just happened?
I hate that.
That is the worst.
Yeah.
Yes.
There's nothing worse than a test that's passing and I don't know why.
The nice thing is that you can still check it into another branch, and then you can do a git diff on it, and then you can start to explore what it really means.
Yeah, the scary thing is that if I don't know why it's working, I don't know why it didn't work, and I don't know when it might stop working again.
I know people and have worked with people that once they have it passing, they're very satisfied with that and don't need to look into it. And I almost envy them that, because I will rip the whole damn thing apart to figure it out. Like, I cannot let it go.
So there's a refinement on TDD that Kent Beck talked about recently maybe a couple years ago, where he phrased it as calling your shot. So like when you're playing pool and you're taking a shot, you say, okay, I'm going to put the 12 ball in the corner pocket. And then if you accidentally hit the 7 ball in the side pocket, your shot's no good, right?
Oh,
so in TDD, when you write a test that you expect to fail, you want it to be read, what you do is before you hit run, you say, oh, this is going to fail with a record not found error.
I actually do that, and I had no idea it was a Kent Beck thing. It's just, I spend a lot of time pairing with people, so I like to say, this is what I expect, so that I can't, to keep myself honest, really.
Yeah. Well, it's also an important part of the scientific method is you want to make sure that you're testing the right thing, like your experiment is actually set up right.
Yeah.
That's falsifiability, right?
Yes.
Or something along those lines.
Or is it like the null hypothesis? Wait, I forget all that. Never mind.
Yeah.
I just like being right.
Well,
Really, I like
actually,
being wrong. Wrong is much more interesting.
yeah, you learn more when you're wrong.
Basically, what we're saying is the saying, I'd rather be lucky than smart, is wrong. Because luck is not reproducible.
Not according to Katrina.
It's true.
Katrina is smart enough to look lucky.
What's that lyric? It's smarter to be lucky than it's lucky to be smart.
Yeah.
Nice. You have a great slide in here that kind of goes back to the earlier mindset thing. And I want to talk about it because it took me a while to figure this out, I think, for myself. But you have the great quote in there of Sherlock, I need to go to my mind palace. And I love that one. It's like when you're totally hung up on the problem and you just stuck, and it's like Avdi says, you've got the blinders on and you're so deep in it and you think, I'm just going to dig deeper and you can't let it go. There has to be some way to break that chain. And going to the mind palace, quote unquote, is a great way to do it. To have something that just resets your thinking, right?
Yeah, Mind Palace is actually a memory trick that helps you see what are just the associations between the things I know. I mean, we all have a lot of knowledge. I mean, anyone listening to this has a lot of knowledge. Those sort of people who go out and try to learn things. But it's weirdly hard to make use of that knowledge.
I find for me, the secret trick is leave the computer.
Yeah.
Once I do that, it changes the way I think about things. And then that's all I need for the reset,
My way of dealing with it is very similar, except I will actually head over to a local restaurant, coffee shop, or cafe. And again, that little break and then just being in a different environment, I don't know, it makes me think about things a little bit differently.
Yeah, very effective.
Yeah, I also like to just list out here are the things I know. What do those things imply? And just like the physical act of writing out a list is actually very helpful. I don't like to type it. I like to write it by hand on a piece of paper just to force myself to go through that process.
There's a little tiny debugging trick that I thought I'd bring up at some point here. It's not exactly related to anything we're talking about right now, but I think it was in the book, The Practice of Programming, that introduced the idea of debugging numerology, which basically says pay careful attention to numbers that appear in your bugs. Often a number can give you a clue to where the bug comes from. And I remember I put this to use once a long time ago when I was trying to track down a memory leak. And I had managed to put some diagnostics in, some memory leak diagnostics in using a tool. And I managed to find that there were exactly 100 allocations that weren't matched by deallocations. And I hadn't tracked it down. Either I hadn't tracked it down to the line of code, or it was a line of code where there were also lots of legitimate allocations going on. But the 100 turned out to be the clue, because I was able to think about it for a little while and then realize what was the one thing that happened exactly 100 times in the test scenario. And so that's just another tip that I've run across is pay very close attention to numbers.
So that reminds me of the 500-mile bug, which is one of my favorite.
This.
Right. This is just, you Google for it, it'll be the first result.
Mm-hmm.
And it's this wonderful story about this guy who gets a bug report, which is, we can't send emails that travel more than about 500 miles.
Yep. Insufficient postage.
So insane.
They didn't have enough postage.
Yeah, they get really tired.
And it turned out to be an issue with the speed of light.
Yep. That's amazing. I've had definitely along the number lines, you can run into bugs where it works the first time, but it won't work the second time, right? Or things like that. So if you can see how many times you're trying it or something, it can help.
Mm-hmm. Have any of you guys worked through the Deedle and Deedle books? Like C++, I think they're called the explained books, but they're these big blue softbound textbooks. So they're really heavy duty, and they go through the whole language, and they've got them for Java and C++ and whatnot. And they do a wonderful thing early on, and they basically give you a for loop that says, for, 1 to 10, srand time, and then print out, a random number. And you run the program and it outputs the same number 10 times in a row. And then you put a debug break statement in it and you step through the code and you get a different number each time. And they're like, why do you think that is? And then they let you sit with it to really think about it. And then they go on to say, time only updates once a second. And when you're stepping through it in a debugger, it takes you a second to get through the for loop. But when you run it as a program, it's all over instantly. And they do it deliberately as a lesson of stuff can come at you from way outside your box of things of all that you know. And that's where you're going to learn something new.
That's, I always think of bugs like that whenever I put in a put statement or something to see what's going on, and that changes the results.
Yeah.
Like, because I slowed it down with some I.O.,
Right.
Like, race condition, that's the first thing I think of as soon as I see it.
Heisenbugs where, observing changes what you're observing.
Right.
Mm-hmm. I had a code break that I put a put statement in it at the end of the method. Well, puts returns nil, and the previous line was returning something useful.
Right.
I've done that one.
So Danielle, you used one of my favorite words, which is Heisenbug. Can you give us a definition?
Well, I think of that as the sort of bug where the very act of observing it changes what's happening.
Yes.
Okay, so the observer affects the outcome of the observation. Okay, I have a similar kind of word that I also love, which is Hindenburg.
All right, what's that one?
That's just a bug that you think it just like comes out of the blue and explodes and destroys all your data.
That's awesome.
So Danielle, speaking of Heisenbugs, how do you feel about debuggers?
Yeah, let's do the debugger question.
Sure, they're useful. I don't like turning to them first. That's the short answer. I think they're, absolutely useful when you need them, but I have to admit, I like print statements and actually reading my code first because I like forcing myself to try to understand it. Mm-hmm. I find that helpful.
Interesting.
Are there particular techniques that you use for doing source code inspection when you're trying to debug?
I mean, I use pry a lot in the Ruby context. For the most part, and I like being able to see where things are defined and what the actual source of the actual thing I'm calling is.
Okay, so you like an interactive tool that lets you explore the code?
Yeah, once I get to the point where I feel like I need that, exactly.
What about, was it Prag Dave or Jim Wyrick who was talking about zooming your source code really small so you can see the shape of it?
That's Dave Thomas.
That's in Pragmatic Programmer in the original book, yeah.
Yeah, it's just look at the shape without getting lost in the details.
It's an interesting trick, right? I mean, you see the big methods bunch up and stick out,
I do that. I did that, and I'm such a visually oriented, spatially oriented thinker that I will do that with full-size source code on the screen, where I will go in and I'll do an extract method, and I'll read over the code real quickly to make sure, I've got all the variables I'm extracting, and then I do the rest of the edit based on shape. I literally will extract the method and not read what I've written. I'll just go, it's shaped right. And I'll run the unit test to see if it worked. And if the test passes, I often don't go back and read the code. Am I committing career suicide here?
Just keep talking. I'm sure it's going to work out fine.
Yeah. Just keep spooling rope, dude. We just, need a few more coils in the noose. No, but the point is that the shape is so valuable. The visual shape of your code is so valuable that you can often extract and move code without stopping to read every jot and tittle to make sure it's right. You go, yep, the shape looks right. Or you can look at some code and go, the shape on that is wrong.
Yeah, I've only done that second way. That looks wrong. I've never tried to use it in terms of this looks right and I trust myself in that sense. It's really
no, the shape looks right and I trust my unit test. That's
well, yes, that one I do. I certainly do I've copied this, I'm too lazy to read it. Let's see what breaks when it fails.
Yeah, that's closer to it, yeah.
Okay. Are there other kind of tricks that we use to navigate the code and find interesting places to look at for problems? What about churn? I think we talked about, Dave, you said, like, look for within 3 lines of the last change.
Yeah, I think I was quoting Jarvis with that one. Oh, someone just linked to a git churn script that gives you the most recently changed files, or files in the order in which they were changed. I'll have to dig up the link for you guys. It was really wonderful.
Metric foo includes the churn gem as well.
Yeah, there's definitely ways to look for it. You have those things on the project where every time there's a major bug, it's in there, right? Or whatever, those things. The usual suspects. That's how I think of those.
Yeah. There's a strong...
Which for me, by the way, the usual suspects is whatever you introduced in the project plus the Rails autoloader.
Oh, God, yeah.
Yeah. There's a increasingly strong argument, like we were talking about production versus debugging, where I'm really getting on board with dependency injection to decouple things, or at least specifically to decouple things, so that if something is breaking, I would love for it to break on its own merits and not because it's got an implicit dependency on something 3 levels away. And if you use dependency injection, you can't get away with an implicit dependency 3 levels away. You have to have an explicit dependency, and you can actually see the unit tests setting up and tearing down that, yeah, we're actually depending on this thing three things away. And that's a code smell that you can come back and fix.
Yeah, but sometimes you need to fix something and you don't have the time to completely refactor it first.
Oh, yeah.
Mission critical thing. You have to do it now. That's why I start like commenting out bits of it and changing it to, I'm not injecting dependencies. I'm just changing other pieces of this method to simplify it.
Yeah, sorry. By dependency injection, I'm talking about the way I write new code. Yeah.
Yeah, I mean, that's certainly absolutely the ideal.
Yeah, I try to avoid things like, in mocking frameworks, methods like any instance or something like that.
Yeah.
That's a good sign that I've just totally lost control of what's creating what,
Yeah, I like how in the RSpec documentation, they put any instance like way all the way at the end and preface it with a whole bunch of reasons why you should really never be using this.
Mm-hmm.
We only include this grudgingly.
I remember back in like 2008 when mocking frameworks were like starting to become a big deal in the Ruby world, and it was all like RSpec mocking versus Mocha versus double R, and the existence of the any instance feature was like the make or break feature for a mocking library. Mm-hmm. And now it's like stay away.
Yeah.
Oh, how practices change.
Yeah.
This feature is sometimes useful when working with legacy code, though in general we discourage its use for a number of reasons, and then there is a series of bullet points.
Yeah.
Exactly.
Sandy nailed down the rule that causes that code smell, and it's a file that contains a class should not refer to a hard-coded class of any other class. Yep. Yeah. And that's the injection. But like we just said, sometimes you have to debug the code you have, not the code you want.
Right.
Yeah.
Sometimes.
Yeah, sometimes.
Danielle,
is that something like the code that Gotham deserves rather than the code that
Yes.
Oh, I heard that as you go to war with the army you have. Yeah.
Nice. Danielle has great tips on that, though. Like, treating the rest of the system as black boxes, commenting out as much as you possibly can, like, you verified it's not in this thing, then just stop using that thing, and replace it with some one-line stub or whatever, just to narrow in on the real problem. Right?
Narrowing in is so important, and so if you're a scientist, you talk about this as isolating variables, and if you're constructing an experiment, the most valuable thing you can do is test changing one thing at a time. Because if you're changing 2 or 3 or 4 things at a time and you get the result you wanted, you don't know which of those things produced that result.
I only sort of agree with that. I mean, if you have a lot of things, if you change half of them, and then at least you can do a binary search through the things that you want to try changing. Okay,
that's a great point. I mean, trying to narrow down from a large set to that small thing. There's a lot of techniques for doing that. That's a great example there. Yep. But in the end, you want to narrow down to finding one thing.
Absolutely,
you don't want to commit those large set of chances. You want to commit the one that's right.
No, this is when the reset thing is critical. Yeah.
Yeah, exactly. But you had a point about that in your slides, Danielle, talking about Miller's Law. You want to bring that up?
Oh, sure. Miller's Law is that the average person can only hold 7-ish items in their working memory at a time. So we have our puny little human brains, and we can't actually keep track of anything. And we just have to accept that and get rid of things.
So by commenting stuff out or whatever, you're saying, okay, I won't have to keep track of that.
I don't have to understand that to fix this. I don't have to keep track of that. You have to lessen the cognitive overhead in order to be able to focus on the few things that matter.
You only have 7 registers in your processor.
Right.
Right.
Yeah, exactly. I mean, and if you're going to go in and try to fix something in a huge system or a system you're new to, there's no way you're going to actually be able to learn or understand all of it or think about it at the same time.
I actually love it when I can fix code and not understand what it did. That always makes me feel great. Like, I just narrowed it down. It's got to be happening in here. The tests tell me everything's okay. When I flip this one thing over, everything goes green. We're good. I have no idea what it's doing, but that works. I think that's cool.
Oh, yeah. For me, it's fixing bugs in code where I don't even know the language.
So
Right.
I do that. But I want to hark back to a few minutes ago when we said getting lucky doesn't count. The talk that I referenced about the Air France flight, he includes a definition of root cause, and it's a beautiful definition. Root cause is the point we were at when we quit looking.
Nice.
Yeah. On the topic of narrowing down, another technique that might be worth bringing up is if it's code that I don't know and don't understand as well, one thing I like to do is just start going through and putting assertions in. Just basically validating my assumptions line by line, put in an assertion, run the tests or run the scenario or whatever, and then put in another assertion. Because a lot of times we look at a piece of code and we convince ourselves that we know exactly what it's doing, and we're completely wrong. And, particularly what I see a lot is either we miss a conditional, like if somebody has stuck a conditional way at the end of the line or something like that, or we just assume that the circumstances can't possibly be such that a particular conditional branch is taken. And so just going through and putting in assertions that, the code will get here, or that this value will not be nil, or that this value will be nil before switches that are made on that value and stuff like that, they can really validate your assumptions and narrow down the problem space.
I will do that with unit tests sometimes. I feel weird doing this, but I call them PNE assertions, or PNE, it's a chemistry term. It stands for poof, no eyebrows. And what it,
I love it.
What it means
You
is,
mean like that was in your chemistry books in school?
Yeah.
I
I mean like, I just, I did an experiment and I expected some outcome, but I did something heinously wrong and my chemistry set exploded and now I have no eyebrows. And so sometimes,
Dave, that's the Hindenburg.
that's the Hindenburg. Yes. So you get like this weird conditional right at the end that's supposed to catch something that only happens once in a blue moon, and it turns out that we don't actually have a conditional for it. We don't think this can ever happen, but we don't guard against it because we don't think it can ever happen. And so you go down to the end of the thing and you basically say, look, we don't have time to write all of the guard clause and the catch and the set up the framework to have the external service return the weird thing. So I'm just going to write an assertion right now that if this method receives this illegal data, it should PNE. It should Hindenburg. It should blow up. So you read the test suite and you're like, wait a minute, why are you writing unit tests that say this should blow up? I say, well, I'm documenting that we have not covered this. And yeah, if you drop a stick of dynamite down this particular exhaust port, I'm mixing metaphors here, but, the Death Star should blow up if you shoot a torpedo down this exhaust port. That is, we're not going to fix this design flaw. So the correct behavior is it should all blow up. And if that turns out to be a real problem in production, we should come back and fix it.
Yeah, the external version of scattering assertions around is the characterization test, where you just write some tests to validate your assumptions about some code that you didn't write or don't remember. I'm actually a bigger fan of putting the assertions straight in the code and making sure that the code is exercised rather than writing lots of characterization tests.
Yeah.
Very cool.
It sounds like we're kind of winding down on the topic. Is there anything left to cover here?
It's been a fantastic.
Danielle, you mentioned something that I like in your slides. You mentioned open gem or bundle open.
Yeah.
Yeah, just as a way to open up the version of a gem that you're actually using and, say, put in a debugger or check your assumptions about what's going on in the depths.
I'm waiting for James to
I'm over here steaming, but I'm trying not to say it.
Say it.
I promise I'm pristine when I'm done.
That's actually a key point that not everyone knows. Do you want to explain that?
Oh, that's so, yeah, after you've been messing around in your gems and you've made a big mess, if you run bundle pristine, that will actually return them to their nice pristine state, so you don't screw it up for yourself later.
Nice.
Right. That's my complaint, is that I see people do it, and I don't see people follow it with pristine.
Oh, that's a problem.
And that would be a difference between development and production when you're doing it.
And again, a lot of people don't know about gem pristine, but I really do like the technique of just opening the gem using bundle open or the open gem. There are a couple of those. Because on numerous occasions I have convinced myself that I am looking at the right gem, the right source on my disk, and in fact I'm looking at the wrong one, and the one that my code is actually using is a different version sourced from a different place on the disk. And so I just sort of filled my head with lies by looking at the wrong thing. So yeah, if you can actually tell Ruby to open up the thing that your program is using rather than making assumptions about the thing your program is using, much, much better.
So I love that technique, used with caution. I ran into a wall doing that once, and I had to do the second order technique of that, which is I was trying to figure out what was going on in one of these authentication gems, and I forget which one it was. Maybe it was AuthLogic. It was so heavily refactored inside that it was really hard to understand the control flow within the code. And I was trying to find where it was actually doing the database query to fetch the user record that it was going to do the authentication test on. And I couldn't, it was like I looked through the code for almost an hour and I couldn't find it. And so I just dropped down into active record and raised an exception in the code that, did active record find.
Yeah. And then looked at the backtrace.
Yeah. And then I looked in the stack trace and I saw where in AuthLogic it was doing its thing.
Nice.
Yeah, that is the technique that I use sometimes to just a really cheap way of finding the backtrace.
Yeah, so
I'm hesitant to use that one because I feel like sometimes I do that and it turns out there's a rescue in the way and I never actually see it anyway.
There is that.
That's actually a really good test, though. If you raise an exception and nothing happens at the top level, somebody's rescuing that, and you need to go find out who's rescuing exception and stab them in the face.
Yeah, but if you do that in Rails, your odds of it happening are like 60%.
Well, and this is also the case where after a little bit of trying and failing with that technique, that's where I'm going to haul out the debugger.
Yeah.
I do find the debugger useful for stepping through other libraries and figuring out just what the heck is going on in them.
Yeah,
right.
When you say the debugger, are you talking about something like the debugger in RubyMine, or are you talking about the debugger gem?
So I'm usually talking about something like the debugger gem, and this is one of my points of major angst with Ruby, because as Danielle, you pointed out in one of your slides, there are 3 different debugger gems for 3 different versions of Ruby.
Yes.
And it is a Ruby tradition that a new version of Ruby will be released many months before somebody comes up with a fixed debugger gem that actually works.
Yes.
So, and this is one of the many reasons that I say never ever trust a debugger, because for one thing, on the day you need it most, which is the day that you upgraded to a new version of Ruby, you will suddenly discover that it doesn't work anymore. Mind you, this is a bigger problem in Ruby than in some other language ecosystems where they actually care about debuggers. But yeah, I do think that people should know how to use just the basic command line debuggers. Also, as Chuck, as you were saying, RubyMine puts a front end on the various debugger gems that can make it a lot nicer. You can have watches and you can have really handy breakpoints and all kinds of good stuff that you would expect in a full IDE. The only downside is that because it's trying to find out all sorts of stuff for you, it winds up calling methods on your behalf that you don't know about. And so the IDE is doing things like, something .inspect in the background or something .class in the background. And if the problem is actually if it's a tough one because it's because of some kooky monkey patch or something where .class breaks, you can actually wind up with weird second order errors as a result of the debugger trying to find out information for you without asking you, and things break. You think you're getting to the root of the problem because you're seeing these new errors, and in fact they're unrelated. They're just sort of other crap getting in the way. So you got to be careful with that stuff, and I think it is a good idea to be familiar with just the raw command line debugger.
Yeah, the less tactful your debugger is, the more likely you are to generate Heisenbugs.
Right.
So I have another question that's related to figuring out where bugs are, and that is fixing bugs. Is there certain etiquette to that? Or do you just go in and just, ram your code in there and make sure all the tests still pass?
It depends. How down is production right now?
Right.
Like, are you not serving requests at all? Are you unable to take credit cards? What's the current status?
So let's assume, if it's down, the business needs it to be back up so they're not losing money they would otherwise make, right? But, just in general, if it's something that's not as critical, I guess, or, it's something that's just going to be pushed in the next release.
Well, what about, one of these two wrongs make a right situations where you have a bug that's not biting anyone too badly, but fixing that could make things worse by making another bug bite you more often.
Like surfacing another bug,
Yeah.
Yeah.
That's the time when you need to take a step back and do some design work, right?
That's the time when I feel like changing careers.
That's the time when I think about changing religions to one that lets me drink.
Oh man, it just makes me think of poetry. There's this Kenneth Koch poem, "One train may hide another," and I always think of it, one bug may hide another.
Yeah. Good point.
So that's actually, I think, something that happens to us fairly often when we're debugging, is if you're not aware that there's perhaps multiple bugs going on, you fix the bug that's in front of you, and things still don't work.
Right.
Right.
The reality is things are actually improved because what you had was 2 layers of ignorance that happened to be lucky, and you've removed 1 layer of ignorance, and now you're a lot less lucky. I don't know if 2 wrongs make a right, but 2 nots do make an equals, and that's kind of profound. Anyway, you've removed that first layer of ignorance, and now you've got a real problem. And do you deploy that to production, or do you maybe push that off into a story branch and say, guys, we got to take care of this?
Making that choice is, I think, in the situation where you have all the information is a lot easier than us talking about it abstractly.
Yeah.
But the hard thing, I think, is being able to understand that there's multiple bugs interacting here and that you actually have made things better, even though it seems like things are failing more.
Right.
Although, for some definition, that's making things worse.
Failing doesn't have to be a bad thing. Like, there have been times where the right thing to do in code was very difficult, but the chance that it would fail was very small. And, and this depends, obviously, on your use case a lot. For example, Twitter, at the rate they take in tweets, something that fails 1 in a million times is a matter of seconds. So obviously they need a failure rate much higher than that. But it can be okay to let something fail, especially if you can detect it and communicate correctly with the user or something. Then a lot of times it doesn't matter. And sometimes it's worth throwing the failure in there, recording the metric. If you can recover correctly, record the metric and move on, and then wait and see. Are we talking about something that's happening once a month or, once an hour,
So going back to what I think Avdi was saying about using the command line debugger tools, a friend of mine has been doing some really fun stuff lately where she's decided that sometimes reading Ruby is too annoying. I'm just going to use strace instead to understand what's really happening and what the system calls are rather than parsing through the Ruby.
Wow.
I think I know who you're talking about.
You probably do. I'll put a link here. It's Julia Evans.
That's a little hardcore.
I love these blog posts so very, very much.
Oh, yeah.
Is this going to hurt my head?
These? I think I've picked these.
I don't know.
I would have, but I can't figure out which ones to pick because I love them all so much. She does these things where she's like, I wrote a kernel and it sort of turns the screen red and it hangs, and that was really cool. So,
that's amazing.
But yeah, this idea of just seeing, what are the system calls? I don't need to think about the high level language. I just want to understand what's happening on this low level and sometimes simpler levels is really nifty and really interesting.
That is very interesting. It's another way of changing your view, right? You're looking at it in a different way than you were before.
It also gets over the fact that, strace gets over the fact that one of the big problems with debugging into Ruby is that we don't really have in the regular debugger, we don't really have a view into the C code.
Right.
That's a point where we had no debugger. We were using a version of Ruby that didn't have a debugger, and we managed to cobble enough of it together using set trace func, which is a Ruby call that is exposed to your Ruby code. And so we wrote a debugger with it. And if you haven't played with set trace func, that's fun. It's worth looking at.
Actually, if you haven't played with it, don't. In the newer versions, play with the object-oriented API that they have now. It's Tracer, I think it's called, or something. Way cooler. You can turn it on and off for given sections. You can do really cool stuff with it.
Tracer or Tracepoint?
Tracepoint, that's it. Thank you.
Okay.
Yes, thank you. All right, should we do some picks? I think we've pretty much covered it.
I think so.
It's been a great chat.
It really has.
Absolutely.
This has been a lot of fun. Thank you for having me on.
This is one of those episodes where I'm going to have to go back through and make a list.
I think it's pretty high on the brain breakage meter.
Yeah.
That's a good sign.
Yeah.
Yeah, I be proud of that.
Stuff I got to look into.
Awesome.
All right, let's do the picks. Josh, do you want to start us the picks?
Sure, I'd love to. I have two fairly relevant picks. So my first one is going way back to 2009. So Nick Kallen gave a presentation at Goguryko in 2009 called Magic Scaling Sprinkles, where he talks about a technique for tagging all of the log entries from the various servers in their system with a unique identifier that propagates through the system. So if you get a request that comes in, in the front end system, you put a token on it, and then as that flows through the different layers of the system, all the logging gets associated with that. So if you have an issue, you can unify the view of that request across all the different pieces of the system. And that was a pretty cool trick. So I think that's relevant to how we debug this stuff. So that's one. And then Mislav Marohnić did a post last month about every line of your source code is documented, where he talks about techniques for using Git to investigate the history of your source code and understand why changes were made and in what order. So that's a very good post on a powerful debugging technique. And that's it for me this week.
All right, James, what are your picks?
So I just have one. It's not totally debugging related, but the thing I've been debugging lately is I finally built a system that uses the Russian doll caching technique in Rails. So I've had to figure out, how does all of that work, and especially with Rails' invalidation of templates and all of that. So, which is kind of neat. And there's this blog post from Kevin Faustino that is really concise and explains it very well, I think. So this blog post has been very helpful to me in getting my head around how all the caching stuff works in Rails 4. So if you want to know, I recommend this. And that's all I've got.
All right, Avdi, what are your picks?
Pretty much all non-programming related picks this time. First of all, I have recently restarted watching the show Community. And it's a lot of fun. I can't remember. I might have picked it before, but it's a nice kind of replacement for 30 Rock.
Avdi, where do you watch that?
Hulu.
Okay.
Yeah, I have to put up with the awful ads, but
it's also on Amazon Instant Video if you don't mind paying for it.
Oh, right.
Okay. Okay, but it's not in the Prime ones.
Yeah, I don't think it is.
Okay, cool. Thanks.
And since I was a little kid, one of my favorite places in the world to go was the Air and Space Museum. Down in the National Mall in DC. And for years, I have been wanting to go to their adjunct facility out by Dulles Airport, the Stephen F. Udvar Hazy Center. And I finally got to go there. Me and a friend went out there the other day, and it was just as cool as I'd always imagined. They have a gigantic hangar there, and they have just an amazing collection of aircraft and spacecraft. They have an SR-71 Blackbird, and they have the space shuttle, one of the space shuttles, and I got to get a picture of a launch vehicle that my dad worked on, and cool. Just an incredible collection of aircraft all through history. They have there all the stuff they couldn't fit in the main Air and Space Museum. So I highly recommend checking it out if you're ever in the DC area. And one other thing, I saw that NEO, the company that Jim Weirich was involved with, has created a fund in his memory, the Weirich Fund, and it looks like it's going to be funding a scholarship for somebody to learn about computer programming. And that seems like a pretty cool cause in Jim's memory. So that's something to look into. All right, that's it.
Cool. David, what are your picks?
Okay. Dorothy Parker once wrote, "The cure for boredom is curiosity. There is no cure for curiosity." And I have two picks today that are all about curiosity. My two favorite ways to explore curiosity are looking at things and learning about them. So my first pick is a microscope. It's the My First Lab Duoscope microscope. You can get it on Amazon for like $60. It's really cheap. It's basically the highest end kids toy version of a microscope you can get. And by highest end kids toy, I mean it's got actual real glass optics. So the functioning parts of the microscope are real. And all of the other kit stuff is kind of chintzy and plastic, but it works like a real microscope, and you can actually, look at cells and stuff like that. It's very, very cool. The second way I love to explore curiosity is building things. And I was going to pick Make Magazine, but I see that James picked it a while back. Been a while enough though, so Make Magazine could probably be a second pick. But they have they're running an ad right now for an iPad game called Moe's Resistance. And one of the hardest parts of getting into electronics is learning the stupid resistor color codes. And Adafruit has put out a little $1 game for the iPad where you can spin the dials on the resistors to try and get the right value and drop it into the circuit without burning up the circuit. It's stupid and silly and fun, and it teaches you to remember your resistor color codes, and it's a lot of fun. So those are my picks.
Awesome. I'll jump in with a couple of picks. First off, I've been looking at doing some iOS development with iBeacon stuff, and most of the iBeacon hardware out there is you can get a unit from anywhere from like $40 to $100. But I've had this Raspberry Pi sitting on my desk forever, and so I was wondering if you could do it with that, and it turns out you can. So all you need is a Raspberry Pi, a power supply. You can get the SD card with the operating system just off of Amazon for like $8. And then you get a little USB dongle that you plug into your laptop. And the Raspberry Pi has, USB ports on it. So you can just plug it in there. So the whole thing costs about $30 or $40, I guess. But the nice thing is that then you've got this modular system that you can totally hack on and play with. And I found an article that tells you how to make an iBeacon out of a Raspberry Pi. So anyway, I'm looking at playing with that. And then the other thing that it's a little bit of shameless self-promotion, but I'm starting to work on a SaaS product for podcasters. And I figure that most of our listeners listen to podcasts. And so I really just want to ask if I can, if you have a podcast, if you could go to feedwrench.com. It's just a little survey, and really all it is I'll have a list of the features that FeedBurner provides, and you can uncheck any you don't really care about. And then I'll have about 5 features in there, of which you can choose 3 that you really do want that FeedBurner doesn't provide. And that's just to give me an idea of what's important to people. And in the meantime, I'll be doing the development on kind of the critical parts of the app that FeedBurner does. So it's sort of a FeedBurner replacement, except it'll do things like work. So, and it won't have the 512 kilobyte limit on the feed. So anyway, and I've had a few other issues with FeedBurner, so that's why I'm working on it. And every podcaster that I talk to about it gets real excited. So I figure it's a good idea. So anyway, I would really appreciate it if you're a podcaster, if you go fill it out. And if you listen to podcasts, tell the host of the podcast you listen to go fill it out. And that'll help me out a ton. And that's all I got. Danielle, what are your picks?
Sure. So let's see. A few friends of mine are running a conference in New York called Bang Bang Con, which is going to be 2 days of 10-minute talks, which looks really exciting. And I haven't actually submitted a proposal yet, but I should, and everyone should. And that should be really awesome. First thing I'm super psyched about right now. Let's see, like I said, lately I've been playing around with some Clojure, and that's because this guy Kyle, who goes by Aether on Twitter, which I'm probably mangling the pronunciation of, has been writing some wonderful Clojure tutorials called Clojure from the Ground Up. And he's really sweet. I pinged him and I said, look, do you have a good idea for open source projects where I could just, submit some tiny patches while learning to pretend that I actually know Clojure? And he said, oh yeah, I do this Remon thing. You should totally submit to it. That's that monitoring library that I was mentioning that deals with monitoring events from distributed systems. And I've just been having a really fun time messing around with the code there and contributing to it. And it's a really interesting library. I haven't actually used it. I've only written bits of it, which feels a little bit backwards, but has been really fun for me. Beyond that, mostly I just wanted to list a few books that do feel relevant and useful to me. I really like Daniel Kahneman's Thinking Fast and Slow, which came out a couple of years ago, and it's all about how we sort of have these two ways of thinking through things. We have this fast system and the slow system, and the fast system is where we use our heuristics and we jump to conclusions and we do all those things we spent the past hour or so talking about trying to avoid doing. And we have our slow system where we pause and we actually go through things and try to understand them and catch ourselves. And it talks about how to force ourselves into using the slow system instead and different kinds of cognitive biases you can learn to recognize and avoid. I also really like How to Solve It by George Pólya, which is about solving math problems in theory, but it feels like it's full of useful problem-solving tricks generally. Mark Hedlund over at Stripe recommended that I read a book called How Doctors Think by Jerome Groopman, which I thought was wonderful. And just talked about a lot of tricks to make sure that you're diagnosing health problems, how doctors figure out how to diagnose what's going wrong based on the symptoms that people tell them about. And a lot of ideas there felt really, really generally applicable and useful to me.
These are great picks. They're actually relevant even.
They are great.
Okay, 2 more relevant books then. Fine. I can list books forever. Working Effectively with Legacy Code by Michael Feathers. That's where I first learned about that trick where I don't know what's happening, let me write a test just to understand what's happening and document the existing behavior. Not to prove that it's working correctly, not to prove that it's doing what it should be doing, just to document what it is doing.
Yes.
I just, perfectly obvious in retrospect, but didn't know it until I read that book. And, I can't remember anything else I learned from that book, but it was worth that one idea. I'm sure there were other useful things in there. I should probably reread it. And the other book that comes to mind immediately is that I think I mentioned this earlier, Coders at Work, which is just a bunch of interviews that Peter Seibel did. And he asked a bunch of really interesting people things like, how do you approach debugging? And, do you read other people's code? And full of wonderful, wonderful stories.
Cool.
That's very cool. All right. Well, I guess we'll go ahead and wrap up. Thanks for coming, Danielle. It was a very, very interesting conversation.
Thank you. I had a lot of fun. I really appreciate it.
Thank you, Danielle. We appreciate it.
All right. Well, we are doing our next book club book. It's going to be in about a month, if I remember right.
May 9th.
May 9th, so a month and a half. And that will be Object Design. And we're going to have one of the authors on the show, Rebecca Werfsbrock. So go get it. Apparently it is on Safari Online, which seems to be the best way to get it. And you can also find it on Amazon, though it's out of print, so it's a little bit pricey to get there. But anyway, pick it up, read it, and we'll talk about it then. And besides that, thanks for listening. Hosting and bandwidth provided by the Blue Box Group. Check them out at bluebox.net. Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more. A special thanks to honeybadger.io for sponsoring Ruby Rogues. They do exception monitoring, uptime, and performance metrics and are an active part of the Ruby community. This episode is sponsored by CodeShip. CodeShip is a hosted continuous deployment service that just works. Set up continuous integration in a few steps and automatically deploy when all your tests have passed. CodeShip has great support for a lot of languages and test frameworks. It integrates with GitHub and Bitbucket and lets you deploy cloud services like Heroku, AWS, Nojitsu, Google App Engine, or your own servers. Start with their free plan. Setup only takes 3 minutes. CodeShip, continuous deployment made simple. Would you like to join a conversation with the Rogues and their guests? Want to support the show? We have a forum that allows you to join the conversation and support the show at the same time. You can sign up at rubyrogues.com/parlay.